Okay, my friends, as I told you that you can check any battery at home and check the volts inside. One of the most common batteries that we use in our toys and so on contains 1.5 volts. Take care, as I told you, that this number of volts means the potential energy for each charge separately inside the battery. This energy difference causes charges to flow because the voltage of battery is related to energy per charge. It doesn't tell you how much total energy the battery supplies. Again, here the number of volts is related to energy per charge, energy for each charge. But what about the energy of the battery as a whole? What about the total energy of the battery as a whole? Is it indicated here by the voltage? No. A car battery, for example, and 8-watch batteries both supply 12 volts. For example, the battery of the car supply 12 volts. Okay? And 8-watch batteries, these small batteries, that are present inside your watches, also can supply, 8 of them can supply total energy 12 volts. But 8-watch batteries cannot run a car. And in spite of that, both of them supply the same amount of energy. Again, for a car battery, it can supply 12 volts. If I have brought 8-watch batteries, they will supply the same amount, 12 volts. But can you exchange the car battery by watch batteries? For sure not. Why? Because each charge has the same amount of energy, but the car battery can provide that energy to many more charges. This results in higher total energy. So again, these charges inside the car batteries, or this energy, is supplied to many charges. The amount of charges inside the car batteries is much more, by great difference, than the number of charges in watch batteries. So it will supply each charge with 12 volts, while the watch battery, for example, it will supply each charge inside it by half a volt, right? So this results in higher total energy of the car battery. You can compare the voltage to the gravitational potential energy per kilogram as the picture that you will see in figure 4. Here the question: battery A supplies 500 charges. You have a battery that contains inside 500 charges, and each charge has 2 joules of energy. Fine, 2 joules of energy. And there is another battery here, the first one. It contains inside 500 charges, and each charge has 2 joules. And there's another battery that can supply 50 charges only. The number of charges here is less than here. But each charge here contains 4 joules of energy. Compare between the numbers. Battery A has more charges than battery B. But what about the energy inside each battery? Here the energy of each charge in battery A of each charge is 2. And here the energy of each charge in battery B is 4. So the charges here have more energy than in B. Which battery supplies more total energy? Total. When I say the word total, so I will count or get the total energy of this battery. If you have a battery with 500 charges, each charge contains 2 joules of energy. So what is the total energy inside this battery? 2 multiplied by 500 equals 1000. Right? So for battery A, it contains total energy 1000 joules. What about battery B? 50 multiplied by 4, 50 charges, and each charge with 4 joules. So the total energy would be 200 joules. Right? If you have compared between them, so which one have more total energy? Battery B. But which has higher voltage? When I say the word higher voltage, remember the word voltage means the potential energy for each charge. For each charge. Here each charge contains 4 joules and here each charge contains 2 joules. Right? So which one has more or higher voltage? Yes, number B. So the one with more total energy is battery A and the one with higher voltage is battery B. This was for the voltage and how can you calculate the voltage or the amount of energy, potential energy of each charge and the difference between it and the total energy. Now I'm going to talk about the resistance of the current. Sometimes there will be resistance in the movement or the flow of electric current. The greater the resistance, the less current that there is for a given voltage. What is the unit used to describe resistance? It's called ohm, OHM, and this is the sign of ohm, right? Or the resistance. Factors that determine the resistance of an object. How can I judge the resistance of an object? Number one, if you have a wire, for example, I want to determine its resistance. Number one is the diameter of the wire. Diameter is inversely proportional to the resistance. If the diameter is wider, so the resistance will be less. What the meaning of resistance? The number of charges that will flow through this wire. Imagine that you have 2 wires, one thick wire and one thin wire. Which one will allow more charges to move? If you are inside a slide in the aqua park, okay, this slide is like a cylinder. If this cylinder is too narrow, would you be able to pass through the cylinder easily? No. And if it's wide, you will move more easily. So it means that the diameter of the slide affects your flowing rate. The same for the charges. The more the diameter, the less the resistance of the charges. Number 2 is the length of the wire. The longer the wire, the more resistance. The longer the wire, the more resistance. And the shorter the wire, the less resistance. We can apply this also if you are drinking juice by a straw. If this straw is too narrow, will you find it easy for you to suck this juice? For sure not. The juice will move with difficulty if the diameter is small. What about the length? Is it easier for you to use a very long straw or a short straw? Which one would be easier for you to drink the juice? For sure the one which is shorter. So it means that the length of the wire is directly proportional to the resistance. The higher the length, the more resistance the wire. The more resistant the wire. And the less the length or the shorter the wire, the less resistant the wire. Number 3 is the temperature. Also it's directly proportional to the resistance. The higher the temperature, the higher the resistance. And if the temperature is low, it means that there will be less resistance. Okay, number 4 is the material of the wire. As we have discussed before, that we have 2 types of materials, conductors and insulators. Conductors have less resistance for sure. They can allow the charges to move more freely, while the insulator, they have more resistance. They don't allow the charges to move freely. So here these are the 3 factors that can affect the resistance of flow of current. The question here, why is it useful to keep power lines cool in summer? Power lines are the lines that supply electricity to certain areas. Why is it important to keep them cool, not in high temperature, even especially in summer where the temperature is high? You have to make it cooler. Why? As we said, because the temperature can affect the resistance. The higher the temperature, the more resistance. but I need to make the resistance less in order to allow the charges to move freely, right? So I have to cool it down in order to decrease the resistance and allow more charges to move inside these power lines. At the revision for on our lesson, here we are comparing between the electric current and the water current on a slide. Current is made up of moving what in the water on the water current, for sure by the water that's moving on the slide, but the electric current by charges. Potential energy is converted into kinetic energy in water slide, kinetic energy that causes the water to move, but here in electric current, if we have, for example, here a light bulb, it will be translated into heat or light energy. Number 3, the energy source for the circuit, as for example for the water current, for the water current, the water pump is used to supply water, which is the source of water, right? But for electric current, what is the source of charges? This is the battery. I wish that you have understood the lesson and